Hi, my name is Joana Grave, and I'm going to present the results of one of the parts of the study, motion extrapolation for facial expressions using a representational momentum task. The ability to anticipate the motion of a stimuli is critical to interact with the dynamic world. Several studies show that when asked participants to indicate the location where a moving target disappeared, there is a systematic spatial forward displacement in the direction of motion. This phenomenon is known as representational momentum and is described as a motion extrapolation. Representational momentum has been described for simpler and complex stimuli, including emotional faces. In this study, for instance, when asked to adjust a facial probe to match the intensity of the last frame of a face, morphing from a neutral expression to a certain emotional state, participants adjust the probe to a higher intensity, again in the direction of implied motion. However, these studies only focused on the intrinsic dynamics of faces rather than how emotional faces modulate socially relevant events, such as someone with an angry or fearful facial expression rapidly approaching the observer on a collision course, also referred to as looming motion. So, in the present study, we aim to investigate whether motion extrapolation for faces is modulated by the emotional content of the stimuli, in this case, anger, fear, and neutral expression, and the direction of implied motion, in this case, looming and receding implying motion. We expected that in both looming and receding conditions, faces will be misperceived as being forward in the direction of motion, which is congruent with a representational momentum. And furthermore, since angry faces signal approaching motion, while fearful faces signal a retracting motion, we expected that the facial expression would modulate specific directional dynamics, also susceptible to modulate the representational momentum magnitude. 40 participants took part in the study. All of them reported no current psychiatric conditions nor psychotropic medication. In order to address our questions, we designed an original task with angry, fearful, and neutral faces implicitly moving away or toward the observer. In this task, each trial containing a sequence of free stimuli present for 250 milliseconds each and separated by 250 milliseconds of interval. The size of each stimuli was manipulated in a way to imply that the sequence was moving away from the observer, receding motion, as in this example, or to be moving toward the observer, as in this example. One important aspect of this task was that the last stimuli of the inducing sequence was always the same size despite of the direction of motion. After a retention interval between 100 and 400 milliseconds, a probe stimuli appeared in the screen. The probe could be much bigger or much smaller than the last stimuli of the inducing sequence. Participants were asked to adjust the size of the probe to match as possible the size of the last stimuli of the inducing sequence. After the main task, all images were shown again and participants were asked to identify the emotion in each face. For the statistical analysis, we computed the difference between the adjusted size of the probe and the last seen image, always 300 pixels, such that positive numbers indicate a distortion in the direction of motion and negative numbers indicate a distortion contrary to the direction of motion. The values were then averaged by the accuracy in the identification tasks for each individual picture. With these values, we then computed a repeated measures ANOVA with emotion, direction, and retention interval as factors. Our findings indicate no main effects of direction, retention interval, and emotion. There was, however, a significant interaction between direction and retention interval, and more relevant to the present study, between direction and emotion. And as we see here in this picture, compared to neutral faces compared to angry and fearful faces resulted in more representational momentum in looming conditions and in less representational momentum in receding conditions. However, the only significant difference was between fearful and neutral faces in receding motions. Notice, however, that more representational momentum for looming motion and less for receding motion means that the probe was adjusted to a bigger size. So to conclude, we first found, as expected, that looming and receding phases resulted in a positive representational momentum, thus suggesting that looming and receding phases are misperceived as being forward in the direction of motion. Interestingly, angry and fearful faces resulted in an exaggerated forward displacement in the direction of motion, but only in looming conditions, while in receding conditions, neutral faces were the ones that were further extrapolated. This can be described as participants adjusting the emotional faces as being bigger or closer, irrespective of the direction of motion, which might be related to their emotional relevance, but further studies are needed. Also, further studies will help us to understand to what degree are the outcomes determined by the emotional content of the implied motion sequences or the emotional content of the probe to be adjusted. So we'd like to thank you for your attention, and if you have any further questions, please address me by email or visit our lab Twitter or Facebook. Thank you very much.